To help with orienting the HDRI, I'm going to pull in a cropped image of my chrome and gray sphere. For that, let's quickly jump to Nuke. View the ref image and add a crop node. I want to crop the frame to the chrome and the gray sphere. Get the crop as close as possible around the chrome sphere and just keep a little space around it. Switch on reformat in the crop node. And add a reformat node and switch it to square 1K. That's the resolution we are rendering our sphere renders in. And now write this out to HDB10 elements reference and call it chrome.exr. Do the same for the gray sphere. Just duplicate the same nodes and write out the gray sphere. We can now jump back into Katana, and in the catalog I will load in the chrome sphere. Go into HB10 LMRef, and there's my chrome sphere. And I set this as my backdrop in the monitor. I'll do a live render now, because I want the environment light to always update. When I rotate it, I'll set it active for the live render view. There we go, now you can see the chrome sphere render. I show you now a new feature in Katana 4, and that's the multi-view view. You can switch it on in the monitor. If you switch multi-view on to horizontal split, you can get both the images at the same time, top and bottom. At the bottom you can see the image which we loaded, and at top is the rendered sphere. If we look at the catalog, you can select the front and back or the top and bottom image with left and right click. Left click for front or A, and right click for the back or the B image. There are a few different splits, and you can also switch on syncing of both images, which is quite useful. If you want more view like in Nuke with the swipe mode, switch to the swipe modes, and you'll get a line where you can wipe with between both images. All right, let's switch back to the horizontal split view with sync, pan, and zoom on. And now with the end light selected, we can rotate it to try to match the angle. You'll very quickly notice though that we are actually not able to match it, or if it matches, the results look flopped. So it looks like our HDRI is mirrored. Let's fix that by pulling up the command line again and CDing into the HDRI folder. I can just reconvert the environment maps with a mirror flag, and that will give me the desired result. So I just type in the TDL make command, same as before, with -progress, -quality high, -nlatl, and add a -mirror x at the end. Convert both environment HDRIs again, the color corrected as well as the one with the lights painted out. Alright, now hit escape to stop the live render and restart the render to update to the new HDRI texture. And there you go. The orientation looks already much better. And now just spend some time to adjust the rotation until it somewhat matches the reference image as best as possible. Okay, this looks pretty good in terms of orientation. Yes, it's not perfect, but we can refine this later. Let's move on and look at the exposure of our lights right now. Generally, I don't gauge exposure with the chrome spheres, except maybe if I look at the key light. Instead, we'll compare exposure values using the gray sphere passes. Let's load the gray sphere ref image into the catalog and set it as our background, so it displays as the bottom image. And now do a live render with the gray sphere pass. Okay, so if you look at the exposure, my CG render shows about 0.04 on the shadow side and 0.21 on the key side, the side towards the window. If you look at the values on the top left on the monitor, you can see both top and bottom, which is great. because it means it shows both the CG sphere values as well as the reference sphere image values. So it's easy to compare both values now, especially since they're both somewhat lined up. So we know we're sampling similar areas. It's not perfect, so you have to kind of guess a little bit, but it's okay. Now, if you compare the values in the hottest areas and on the shadow side, it seems to be that the ref image is a little bit darker. It's not much. It feels like our light can come down by a quarter stop. So let's just decrease the environment light by that value and let the render update. There you go, feels much better. If we sample it now, the values seem closer, or close enough. Using the gray spheres to match exposure values has two advantages. One, because of the diffuse response of the shader, the light values are averaged a little bit over the surface. So if our lights don't perfectly line up, the values will be averaged, and it's also easier to read the shadow and the key areas. The other advantage is if you have very hot values in your reference image, which might get clipped in the chrome sphere, usually because the dynamic range is limited of the camera, this won't happen with the diffused gray spheres. With the orientation and the exposure of the HDRI setup, we can now move on to adding our window light and the ceiling light. For these lights, I usually would use an area light. But right now, with the current version of 3D Light, the area light implementation does not have a file or a map input, so you can only set the color. Since I want to map the extracted HDRI texture onto my light, that won't work for me. There's also a bug with the current 3D Light version, which causes a crash while rendering if I load a custom shading network material. Hence, that option is not available right now as well. Otherwise, I could create an area light shader, which just has a file input already added as a KLF. Okay, so we'll delete this for now. Instead, what I'm going to do is use an incandescent light shader. An incandescent light shader basically attaches to a piece of geometry and uses the incandescent or the emissive part of the geometry shader to light up the scene. Incandescence is sampled properly in 3D Light, so you will get all the benefits of the lighting without any drawbacks in render speed. First, I will create the geometry using a primitive create and switch it to be a plane. Now you could add it to the sphere ref merge node, but I will create a new group merge node and connect it to the mainstream because that's cleaner. And then add the primitive create node using shift middle mouse to drag them into the group merge node. Let me quickly expand this. Right now, it creates it under the geom location, but I want it to be part of the lights. So I'll change the path to be under the LGT/light geom location and call it a window light geom. So we have this here, and it's just a polyplane. Okay, so for the incandescent light to work, we need a geometry with an incandescent shader or an emissive object. I've prepared a shader which only outputs incandescent, no diffuse, no specular, but it has a texture input. This shader can be assigned to any object which we purely want to use as a light. So we just want a texture assigned as an emissive or an incandescent object. Go to Add, select Look File Material, and go to Look File, Browse, and navigate to the Look File folder. In there, in Light Shader, load the texture incandescent.klf file. And once loaded on the material path, select the incandescent shader. Now, very important, as reference needs to be set to no. What this does is the shader gets loaded directly into Katana and it doesn't just get referenced. This is important, otherwise you won't be able to override any settings of the shader later. Okay, call this incandescent shader and that's it. So now I just need to assign it to my geometry. For that, create a material assign node and drag my shader into the material path, and I will assign it to the light geom location so that any light geometry I create below this location automatically gets the shader assigned. And just to clean it up, let me create a group stack node so that it's easier to create more than one material assign node. All right, now that we have this, I can create my light shader. To create my light, go to the gaffer, select Set Light, right-click, add 3D Light, Incandescent Light, or you can also just hit I and call it Window Light. Under Object, drag the light geometry into the Geometry to Control field. All other settings we can keep as default for now. And now, the one thing we have to do is set the path to the light textures we want to load. And we will do this with a material override. You can add a material node, and I'm going to do this in the sequence setup because this is valid for all the shots again. And I will do this as an override. So switch to override materials, add my window light geometry in here. And from the incandescent shader, I want to set my texture file. So just middle mouse drag the texture map attribute under the drop attributes here field. And here I will load the texture we created for HDB10. Go to folder 01 and load a window texture ending with .tdl. Okay, that's it. Now we're done. The only thing that's missing now is to place it correctly. Actually, one more thing we have to do. Right now, if you were to render this, the geometry would be visible in the camera, which we don't want. So I'm going to add an object settings node under the primitive create nodes. With the object settings, we can adjust object visibility attributes. So add the light geom location to the cell statement of the object settings node and switch off visible to camera. All right, now we are ready to set up the light. And to position it, I will do the same thing again as before. View from the crowsphere node, but I also switch off my isolate node, so now at least I can see where the window is. Select the light and hit W and then V for vertex snapping. Now move the light to the window by snapping it to the window frame. Hit V again once you are done with the vertex snapping. Now we can do a live render. Make sure the ref spheres, the light geometry, as well as the incandescent shader switched on for live updates. Now we can start placing the light, and I'm just going to scale it up, so I kind of know what I'm looking at. But I don't have an interactive view of the texture, so we will have to rely on the render itself. Alright, I'm going to do a small trick, hit escape and switch the isolate node back on, and I'm going to hit live render now. So this should give me a much faster response time. And now I'll just deactivate the isolate node again. The render won't update, but I will have the geometry view visible in the viewport. So I still get the fast response time of rendering without the LiDAR scan in it, which is great, but I can also see the LiDAR scan and know where to place my light. All right, the image is rotated by 90 degrees, so let me just orientate that correctly. Yeah, that lines up better. Now I just want to adjust the light to the window size. And this is the reason I didn't care too much about the correct aspect ratio when I created this texture and just left it square, since we have the window as a guide for the size and for the aspect ratio. I'm just going to adjust this a little bit until it roughly sits in the correct place based on a LiDAR and somewhat matches the HDRI. If we compare it to the previous render, that's not too bad, just a few more adjustments. With the window light positioned, let's set up the ceiling light. Back in the geometry merge node, rename the primitive create to window light PC. Right click and duplicate and call the duplicated geometry ceiling light. Okay. So we've got our ceiling light right now. It has the same transforms as the window light. We will change that in a bit. Duplicate the material override and drag and drop the ceiling light into the cell statement and change the texture path to the ceiling light texture. To render our ceiling light, we have to also create another ceiling light shader. So go to the gaffer, select the Set Lights rig, and hit I to create an incandescent light. Call it ceiling light, and under Objects, drag the ceiling light geometry in there. Now we can start positioning our ceiling light. Now to position a ceiling light, I'm going to use this opportunity to resize it correctly. Now how do we align our ceiling light to this? Well, if we look at the LiDAR scan, we actually have a mid-res version of it in the set. Double-click on the geometry, expand the LiDAR scan, and remove the proxy geometry. If you look at the LiDAR scan itself, which is already lower resolution than the original one, but it still gives us some detail, you can see the ceiling light up here. So that will be our reference to place our ceiling light at the correct spot, and use it also as a scale guide. This will give us a way to validate also the position of our chrome and gray spheres. Okay, let's position and align our ceiling light. You can see there's an offset in the sphere render. We will fix that in a minute. If you look at our spheres, the nice thing is the alignment is pretty good. The orientation seems correct for our HRI. What seems off is the position of our reference spheres, so let me just move them a bit. Okay, now this is lining up much better, and even the window lights seem to be better positioned. We've got our ceiling light and our window light. Now we can go to our environment light and just switch our environment light map to the HDRI with the lights painted out. So select the no lights map, switch the isolate node back on, and now you can run another live render. Okay, if we compare this to the previous one, you can see the difference. Wonderful. All right, now that our HDRI is swapped to the no lights HDRI, we'll have to adjust the exposure again a little bit. I just render the gray sphere and go to catalog. I still have my gray sphere image, so right click on it and load it as second image. We are just a little bit too bright overall, I think. It's got the same as the last time. Let's just try dropping down both lights by a quarter stop. That feels better. I always think I can drop my environment light down a little bit as well. Yeah, that feels good. And now I'll just bring the window light back up a little bit to compensate now that I've dropped the environment light a bit. All right, good. We have our gray spheres and our gray levels balanced.